So now we can talk about the definition of continuity in terms of a three-step or three-part definition, okay? And I'm gonna write it a little bit differently than they do, but let's talk through this first. A function is said to be continuous at a point, so at any x value, only if the left-hand limit of the function equals the function at that point equals the right-hand limit of the function, okay? In calculus, we're gonna talk about this in terms of three things, so let's go ahead and talk about that now. So there's step one that says the function at the point exists, okay? There can't be a hole, right? The function has to exist at that value. Two, the limit as x goes to c of the function exists, okay? And that is the limit, general limit, right? It doesn't say the right, it doesn't say the left. So this is assuming the left hand and right hand limits are the same, so it exists. And then step three, the function at that point should equal the limit that you get at that point, okay? So let's kind of talk through what each of these things mean. So for step one, I'm gonna draw you a counter example. So if this is C, okay, zoom in a little bit, okay? So at step one, this is a counter example. So counter example means a way that you would know it's not true, right? It's against the example. So f of c exists. So if you're coming along and here's a function, bloop, there's the hole. The function does not exist at c, so this is not continuous, okay? I feel like that's one pretty easy to see. Two, the limit of the function has to exist, okay? Well, this is, again, a counter example. So here's c. If it comes in from the left to this point, let's fill that in. So the function exists at c. But let's say as it comes in from the right, it comes this way. So the limit from the left and the limit from the right are not equal, so the limit does not exist at c, okay? And then the third thing would be that the limit does not equal the point. So again, here's a counter example. So here's the function coming in. Here's the function going out. So the limit exists because from the left and the right, it's going to the same place. And the function exists up here at c, right? So the limit exists at c, the function exists at c, but the limit and the point are not the same, okay? So those are the three things that we have to have happen. So this would break rule one, this would break rule two, and this would break rule three. So that's what you're looking for when you're talking about continuity, okay? So let's take a look at problem 6. And they're gonna want you to use those 3 steps to determine if the function is continuous or not. And I'm gonna use the 3 steps by name, okay? So let's look at the first thing. They wanna know, is it continuous or not at 0? Okay, so my first rule, rule 1, says that the function has to exist. My c value is 0. So f of 0 should exist. Well, f of 0 is 1. So the first part works, okay? My second part says that the limit as x goes to 0 of the function should exist. So let's look at the limit. So as I come in from the left, I'm going to 1. As I come in from the right, I'm also going to 1. So since the left hand and right hand limits are the same, the limit is 1. So yes, the limit exists. And then part 3 says, does the function at that point equal the limit at that point? Well, the function at 0 is 1, and the limit at 0 is 1, so this function is continuous. So therefore, this is a little symbol for therefore, it's the 3-dot triangle. Therefore, f of x is continuous at x equals 0. And that would be your finishing statement, okay? But again, you've got to check all 3 of those things. They're a very easy thing to check, but you've got to make sure you go through them in order, okay? Looking at example 7. Given the following graph, determine if the function is continuous or not at the indicated x values. Be sure to include your 3-step analysis and write the concluding statement with justification, okay? You're really only looking for justification if it's not continuous, okay? So not continuous. You'd want to give a reason why, okay? So let's look at x equals -4. We're going to do our 3 steps. So at x equals -4, x equals -4 is right here. My first thing says that f of -4, and what is the value of the point at -4? Well, if you look, there's not one. So f of -4 does not exist. So since the first of those 3 steps didn't work, we don't have to talk about the other ones, okay? Because we've already got one that does not work, okay? So I'm going to say, therefore, f of x is not continuous at x equals -4 because f of -4 does not exist. Okay? Very straightforward. But they are, especially in calculus, they're kind of getting you used to this in pre-cal, getting you to discuss your answers in terms of sentences and in terms of like making sure that you've got a statement to explain yourself and not just writing down a number. Okay, so just start kind of getting used to this. So looking at B, they want to know at x equals -1. Okay, so my first thing is to prove what the point is at 1. Okay, well at 1, there's a point, 1, 4. So f of 1 is 4. That one works. So we'll move right along to part 2. Part 2 says that the limit as x goes to 1 of the function should exist. Well, let's look at the limit. As we go in from the left, the limit is 4. As we go in from the right, the limit is -2. So since they go to 2 different things, this limit does not exist. So that's your statement and you're done because you've already reached one of the 3 statements that doesn't work. So therefore, f of x is not continuous at x equals 1 because the limit as x goes to 1 of the function does not exist. Okay? And you'll notice that it's going to be the same type of answer every time. You're going to say f of x is not continuous at this point because, and then you're just going to rewrite whatever step of the 3-step definition doesn't work. So it should be a pretty easy thing to explain yourself when it's consistent, okay? So the last one, let's look at x equals 6. At x equals 6, part 1, does the function at 6 exist? Well, f of 6, there's the point. At 6, it's 2. So yes, the point exists. Part 2, does the limit as x goes to 6 of the function exist? Well, let's look. As this function's coming into 6, it's coming in right here, which goes to 5. As the function's coming into 6, it goes right here, which goes to 5. So this limit goes to 5 since they both go to 5, okay? So check. Part 3, f of 6 is supposed to equal the limit as x goes to 6. Okay, well f of 6 is 2 and the limit is 5. So 2 equals 5 is not a true statement. Therefore, the function is not continuous at x equals 6 because f of 6 does not equal the limit as x goes to 6 of the function. And that's it. That's the rules for continuity, okay? On the next page, they're going to do the same thing but with piecewise functions, okay? So we'll take a look at piecewise functions in the next video.